In today's video, we're going to look at Walker's claims that their Lights crisps have much less energy, so are better for us than the normal crisps. The Walker's Lights say they contain 30% less fat and that they only have 482 kilojoules per pack. Whereas the normal crisp on the back here, it says that one pack will give you 548 kilojoules. So a sizable difference and will make a difference to a healthy diet. Now, to test their claims, what we're going to do is transfer the chemical energy store in a crisp to the thermal energy store in some water. So let's look how we're going to do this and do this as a fair test. So here we have a normal Walker's crisp. As you can see, it weighs 0.84 grams. And here's our water that we're going to heat to transfer the chemical energy to the thermal energy stored in this water. So obviously we need to know the starting temperature of the water, and the starting temperature of the water is 14 degrees centigrade. It's quite a cold day today. Now the next thing I'm going to do is to light the crisp, and when the crisp is alight I will bring it over and hold it, as you can see, underneath the boiling tube, and we will burn all the crisp. And when it is finished heating, when it's finished burning, we'll measure the final temperature of the water. So here, the chemical energy of the crisp is being transferred. So it's gone out, so I'll need to light this again a moment. So all the chemical energy of the crisp is being transferred to the water. And then when it's finished burning, we will then get the final temperature of the water. Nearly finished now, and there we go. So what I'm going to do first of all is to stir the water. That will ensure we've got an even temperature all the way. Now this has gone up. Oh, it's a big increase. It's gone up to 45 degrees. Now we're going to repeat this with the Walker's Lights crisp. As you can see, it weighs 0.48 grams. Now, obviously there's a big discrepancy, but the crisps are much smaller in the Lights. So your teacher will show you a way in which we can fairly compare them afterwards. So I'm going to do exactly the same again. Burn the crisps to transfer the chemical energy in the crisps to the thermal energy store in a fresh set of water. Now obviously I've got to use a fresh set of water so that we're going to get a fair test. I've read the temperature, it's 14 degrees centigrade. I'm going to light the crisp and then we'll do exactly the same again. So the crisp is alight, so let's transfer the the chemical energy from the water, from the crisp to the thermal energy store of the water. Now, obviously we're not going to get anywhere near such a big temperature rise because the mass of the crisp is less, but we will do something mathematically then so that we can fairly compare them afterwards. So the crisp is just about burnt now. There's a tiny bit left, so I'll just catch that alight. So we get all of that chemical energy transferred. So there we go, it's the last bit there, all done. Now, let's get the final temperature. So the final temperature of the water this time is 31 degrees. And with your teacher then, we'll then look at these results so we can be able to compare them fairly and make an informed decision about which is the healthiest crisp to use.